Hello everyone. Today I will be discussing the topic sequences with all of you. So, if you ask me what is a sequence, in a very easy language, in general language, I'd say that a sequence is nothing but a list of numbers written in a specific order. So note that ordering in the sequence is very important. We can't just ignore the order of the elements of the sequence. We just can't. So a sequence is denoted sometimes by this, or some people denote it as this in curly brackets, where an is nothing but the general term, nth term. It is general term. So a1 will be our first term, a2 will be second term, and so on, like this. So like this sequence, n is a natural number, so it starts from 1. So first term will be n is equal to 1, second term will be n equal to 2, n equal to 3, so on. Sequence 1 by n. So first term will be when we put n equal to 1. So 1, put n equal to 2, half, put n equal to 3, 1/3, and so on. Even this is also a sequence. Sequence of the number 1 repeated infinitely. Now just note that this is not just the set of number 1. No, here this one is different from this one. The placement, this is the first one, this is second one, third one. So that's why I told you can't just ignore the order. Here this is not a singleton one. There this one repeated infinitely many times, where each one is different because the placement is different. Now the question arises, how a sequence is different from a set. How a sequence is different from infinite set. What is the difference? The difference is this, that a set is collection of infinite elements, but a sequence is the collection of infinite elements in a particular specific order. Now just pay attention that the set 1, 2, 3, so on is same as the set 2, 1, 3, or rather it's also same as the set 100, 1, 2, 3. All these are same. It's just the collection of the numbers, the natural numbers. Now the sequence 1, 2, 3 is not same as the sequence 2, 1, 3 is not same as sequence 3, 1, 2, because here the placement, the first term is 1, second term is 2, third term is 3, where first term is 2, and so on. So this is the major difference between the set and a sequence. So mathematically, the definition of a sequence will be a function from set of natural numbers to real numbers. A function from natural numbers we define as an. So for every natural number we have one value from real numbers. Suppose a1 is some real number, a2 is some other real number, and so on. Now we'll discuss convergence of a sequence. In easier terms, convergence of a sequence means a sequence said to be convergent if there is a particular real number towards which all the elements of the sequence are approaching or are converging or moving towards that particular number. I'll give you example. Like we took the example earlier also, the sequence 1 by n, where n is a natural number. What is the sequence? The sequence is 1, 1 by 2, 1 by 3, 1 by 4, and so on. There will be some term 1 by 100, there will be some term 1 by 10,000, and so on. So clearly this sequence is moving towards the number 0. I'll also explain graphically. This is the first term, A1, which is 1, second term, third term, fourth term, 1 4, there's term 1 8, so on. There's all these terms will be like this, 100, 1 by 10,000, and so on. So it will, all the terms will get very near to 0. So as you can clearly see, this is the point where all the elements of the sequence are converging, moving towards. So we'll say that this sequence is converging to the number 0. I'll come to the proper definition and in a minute. So actual definition of convergence is this. We say sequence AN converges to B. This is a symbol used for convergence. Sequence AN converges to a number B if for every epsilon greater than 0 there exists some natural number n0 such that mod an minus b less than epsilon for all n greater than equal to n0. Now let's see what this definition means. It says that for every epsilon greater than 0, so this epsilon is actually arbitrary. For any epsilon this will hold. So for any epsilon there is one natural number such that after that particular natural number, there is n greater than equal to n0, what is happening? Mod of an minus b, that is distance between an minus b, is less than epsilon. What it is saying is this. So it actually means this, that first we have to begin with any epsilon greater than 0, any epsilon, however small, however big, any epsilon greater than 0. There exists some n0. What is happening? That after this particular n0, distance between an minus b is less than epsilon, means every term after this n0, that is an0 plus 1, an0 plus 2, an0 plus 3, every such term is between that particular distance from b. That means this is the distance. Suppose, so epsilon is chosen as this. So what we are saying is there exists some n0 after which what is happening? Every term a0 plus 1, a0 plus 2, every term is in between that distance. So what we are actually saying is, however small epsilon we choose, suppose epsilon is this small, so however small epsilon we choose, however small distance we choose, there exists some n0. Suppose for this epsilon there exists an n0. If we change the epsilon, there will exist some n1. What will happen? After this n1, all the terms will be very close to b, in between that distance. So for every epsilon here, it gives us this thing, that however small we take epsilon, we always find such n0. So this concludes that all the after a particular state, all the elements of the sequence are moving towards the point B. This is the meaning of the definition of convergence. So as we have seen, for some epsilon we get n0. If we change epsilon, we get some n1. If we further change epsilon, we get n2. So this number n depends on epsilon. So please note that this number n naught actually depends on what epsilon we choose. So if we have to prove that a particular sequence converges to B, what we have to do? We have to start with an arbitrary epsilon. Our aim is to get the number n naught such that for all the terms greater than n naught, this is happening. Let's see a question. So as we have seen earlier that this sequence, we know that this sequence 1 by n goes to 0. We have to prove it mathematically using our definition. So what was there in our definition? Our definition said for every epsilon greater than 0. So we have to begin with some arbitrary epsilon. Any epsilon. What we have to do? We have to find n naught. Our aim is to find n naught, a natural number. This is our aim. Our aim is to find this n naught such that mod of an minus b, which is here 0, has to be less than our epsilon for all the terms greater than an naught. Let's see what is mod an minus b. It is mod of 1 by n minus 0, which is mod of 1 by n. Since n is a natural number, it's a positive term, so we get this as 1 by n. Now our aim is to find n naught such that 1 by n, which is mod of an minus 0, is less than epsilon for all n greater than or equal to n naught. Now our convergence gets down to proving this thing. Okay, that's very easy. All of you must be knowing Archimedes Principle, which says that. So Archimedes Principle says that for any two positive real numbers x and y, we can find a natural number n such that nx is greater than y. We all know about Archimedes Principle. There is no need to prove. It's just there for the reference. So here we have the numbers 1, and epsilon. So for these two numbers, by Archimedes Principle, there exists a natural number n, we call it n naught. There exists the natural number n naught such that n naught into our epsilon is greater than 1. We have taken x to be epsilon and y to be 1. Now we had to find n naught. So we have here shown the existence of a natural number n naught. What is happening here? For this n naught, what we are getting is n naught epsilon is greater than 1. This means we are getting 1 by n naught is less than epsilon. Just mark it. Just mark it. Let's call it A. We'll use it later. Now, so I'll again recall quickly. We had to find n naught for which mod of an minus 0 was less than epsilon for all n greater than or equal to n naught. We solved this. We got 1 by n. So our aim was to find n naught such that 1 by n is less than epsilon for all n greater than or equal to n naught. By using Archimedes Principle, we have found an n naught for which this is happening. Now, this is what we had to show, that this is happening for every n naught, n greater than or equal to n naught. So we take some n greater than or equal to n naught, some arbitrary n greater than or equal to n naught. What is happening? If n is greater than or equal to n naught, 1 by n is less than or equal to 1 by n naught, which is less than epsilon from our Archimedes principle we have proved this. So what we are getting is, we already have an n naught for which if we take n greater than equal to n naught, we get 1 by n is less than epsilon. So this is nothing but showing mod of an minus 0 is less than epsilon. So we are getting some n naught for which if we take the n greater than equal to that n naught, mod of an minus 0 is less than epsilon. This shows that our given sequence an converges to 0. So this is the way in which we have to prove the convergence, and I mean every time we have to just work out with this n naught. Here we have used Archimedes principle, in some other sequence we have to use some other thing, but our aim is to begin with some arbitrary epsilon and then to bring some n naught into picture, for which we have to show that mod of an minus n is less than that, mod of an minus b is less than that epsilon whenever n is greater than equal to n naught. And if there does not exist such number to which the sequence is approaching, we call that the sequence is not convergent or divergent. This was the basic starting of the sequences. I'll be covering more topics, so you can also comment what topics you want me to cover. Thank you. Hope you like the video.